this slide is mainly to entice you all to come spend some time in Ithaca, which is a wonderful place. I've just been here a few months. But the work that I'm going to talk about was really done at Boston University, and all the computation was done using the BU compute cluster, which is really an amazing work of art. So let me just give a quick overview of the data set itself and why we bothered to think about sharing this. And the main motivation is that those of us who are curious about commercialization and innovation, we think about two data sets that are kind of disconnected. On the one hand, there are scientific articles, which are in the realm of open science and which exist in kind of one set of data sets, and then produced by universities and to a lesser extent by commercial firms. And then there's another realm of data about commercial innovation, namely patents, also products, if you think about what the work that Gaetan's been doing. And the funny thing is that these data sets don't really talk to each other, right? The data on patents lives in one area, and then all the data on articles in another area. Now, the irony is probably not lost on people on this call that the data about commercial innovation, where we provide 20-year monopolies to corporations that file for patents, is generally free, whereas the data on open science is generally locked up inside of journals and aggregators like that sell that data. But be that as it may, many of us are interested in questions where these two worlds need to be joined. For example, if you look at innovation, where does the inspiration, what is the heritage of scientific innovation? Does it rely on open science or not? And if so, how? And on the flip side, if you start with, say, a university invention, and you want to ask yourself, when do university inventions become commercialized? When do they be incorporated into the real world? You want to go the other way. And that, unfortunately, is much, much easier said than done, because these two worlds don't really talk to each other in a straightforward way. Now, if you want to, by comparison, study commercial innovation, and really, Adam is the pioneer here who pioneered the use of citations from patents to other patents, you can do that because it's in the same world. But looking at citations from patents to scientific articles, or vice versa, those are much, much more rare, is not so straightforward. And that's because of this problem. So if you look at what citations from patents to articles look like, they're a mess. So this is one paragraph from one patent that has 10 citations to different scientific articles. You'll notice that these are all in 10 citations in the same sentence. Sorry, the last one is in the second sentence. There's no titles. All the journals are abbreviated. In fact, there's this hyper abbreviation called IBID, which means use the last reference I mentioned and keep the author and keep the journal and keep everything unless I give you like a new page number, a new volume, a new year. It's kind of maniacal. It would be really, really nice if people who filed patents would just put digital object identifiers in here, so you could grab that unique identifier, just like Adam grabbed the patent number to find the citations, but we can't do that. So, excuse me. So I and others who have tackled this problem employ a variety of machine learning and kind of big data methods to try to find these citations and, importantly, link them to the actual scientific articles that they represent. And without getting into too much of the nitty-gritty, in our particular data set that I'll talk about the sharing of, we use two approaches. One is a machine learning approach, which has been adopted by others. This is using the GROBID, I don't know how to say it, publicly available library, and which we do use, but we also use a set of heuristics. And by heuristics, I mean we do it the old-fashioned way. We do things like, okay, you see this number 27-31, and that could be a page range. But because both numbers are less than 31, that could be a date range for a conference. So we don't want to assume it's a page range. We try to encode a lot of human intelligence. And for now, the human intelligence is beating the machines. Now, I don't know if that'll always be true. We haven't retrained the ML algorithm. We need to do that. But right now, the heuristics find about a quarter more citations than ML does alone. ML finds a few that heuristics don't, so we still use them both. But for now, we're having this two-pronged approach, which burns a lot of cycles and disk space, much to the joy of our system administrators. But that's my problem, not your problem. And that's really all I want to say about the data set. What I want to focus on rather is, and by the way, here's where you can get the data set. It's at relianceonscience.org. And if you go to this website, the first thing you'll notice is at the top it says Zenodo. And you might say, Zenodo? What is Zenodo? What does Zenodo have to do with citations from patents to scientific articles? And why did you put it there? That's what the rest of the talk is all about. So I don't want to say anything more about building the data set. I want to talk about, in the spirit of Red Hot Chili Peppers, giving it away. So in that vein, I'm going to focus on really 5 key questions about data sharing. And I want to frame this in terms of data sharing dilemmas, where there were multiple paths we could have gone down for each of these in terms of what we wanted to share, where we wanted to share it, how, in what format we wanted to share the data, also for whom we wanted to make it available. And for all these that were kind of like, we could do this, we could do that. And sometimes the easy and obvious thing was the wrong decision and we had to backtrack. And so hopefully you can avoid some backtracking and not have to hit the undo button like we did. And I'll hang out our dirty laundry so you can see where we made some mistakes. And then I'll kind of wrap up, if we have time, talking about when, which is, I think, more of a philosophical question, kind of whether and when. Like, do you want to share your data, even if there's not a journal compelling you to do that? And just maybe open it up and talk a bit philosophically at the end. But first, let's go through the first 4 and kind of what we did and how we got stuck. So let's start with the what. Now, the what might sound obvious. It might sound, well, what am I going to share? Of course, I'm going to share the data set that I built. But it turned out not to be so obvious, at least in our case. Maybe for others, it's more obvious. Because in what we were trying to do is different from the obligation you might have when you're sharing data at a journal where you've published an article. And now the AEA data editor, the management science data editor says, upload exactly the data used to create tables, X through Y. And you have to upload code for replication and so on. But that's where your obligation ends. You're not obligated to update it. You're not obligated to write, I don't think, too much documentation. And maybe people will use your data, maybe they won't, but it's more something you have to do. Whereas this is something but I'm talking about data sharing in kind of data sharing that's voluntary, that you want to do. And so if you're thinking about kind of voluntarily sharing data because you want to promote follow-on work, you want to promote just general progress in social sciences, I would ask yourself first off, who are your customers? Because I think before we asked ourselves this question, and by the way, I forgot very importantly, when I say the us, there were a lot of people involved in this, a lot of, especially when we talk about false positives and negatives, a lot of RAs that we hired. But the bulk of this work was done with Aaron Fuji, who works in the IT department at BU, and who I just happened to run into. And when everybody else said this was an impossible problem, intractable problem, he thought of a way to massively parallelize the algorithm so it runs in 4 days instead of 4 years. So without him, this would not have happened. And I regret not mentioning that earlier. Aaron's awesome, and I miss him terribly. But one of the questions we didn't ask ourselves right up was, who are our customers? And that's key for 2 reasons. One is that thinking about who your customers are, even if they're not paying you, can help you broaden adoption, get more users. If you think about what matters to them, what kind of frictions are important, what tools they need, what complementary assets they might require, do they want to link to other data sources, et cetera. And it also might lessen, from a selfish perspective, your support load. You might get fewer emails coming to you saying, hey, why is this variable this way? And why didn't you do that? And so on. And so in that vein, our inspiration was Alan Kay. So who's Alan Kay? Alan Kay was a researcher, let me slide over here, at Xerox PARC in the 70s, maybe 60s, who invented the graphical user interface that you and I use pretty much every minute of every day. And Alan's mantra was, simple things should be simple, complex things should be possible. And so that's kind of what guided our thinking, like, how do we enable 80% of users to do what they want to easily, but also enable the 20% of power users to get where they need to go without dumbing it down too much so they can't do what they want to do. And on the what, and we'll start that way with the what. So the first thing we thought about doing is, well, the output of our expensive and thirsty algorithm is basically, here's a patent, and that patent references this scientific article. And the default thing would be just to give that away. As we thought about it, we said, how are people going to use this? And by people, by customers, we really mean social scientists. Now, as I'll mention, our data is actually open for anyone to use for any purpose, but we're really motivated by spurring work in the social sciences. Might have been a bit different if we were more oriented towards paying customers or commercial entities. And we figured that most of our customers probably just want the count of citations. In fact, if you look at is it hundreds or is it thousands now of papers, Adam, that use your data, most people are using counts. Now, other people are doing more sophisticated things, but if you look at the first article published using our data set, this came out last year, actually. So Madeline Neeland, Melissa Schilling, and Barak Aronson have a table where they count the number of citations of articles cited by a patent and infer something about exploration versus exploitation. Just yesterday, a colleague here at Cornell sent me a working paper, and guess what? His table looks just like this. It says, I'm using your data to create a count of papers or articles cited by a patent. And so if we could get 80% of the way by very simplifying what we do and just saying, for this patent number, here's the count of articles cited. But if we did that, we would be shutting out the 20% who want to go deeper, who want to know what sorts of papers were cited. What's the originality or the age of the scientific articles? Are they citing older versus newer? And if we just had counts, we couldn't do that. So we actually did decide to share the paper and the patent and the article, so you could do sophisticated things like that. But that quickly drug us into a second stage of, well, if they want to know which paper was cited, they want to know information about the paper. And so we had to give that sort of information as well, which brought us to a second decision under the heading of what I'll call complementary assets. Now, before I get there, we are using a probabilistic matching algorithm, which means we're going to make errors. And when you're doing probabilistic matching, you have a dilemma, which is, do I just share the matches that I'm super, super sure of, or do I include more matches? Now, it might seem like an obvious thing. Well, most researchers will say, I don't want any errors in the data set I'm using. And so don't give me any matches where you're not absolutely sure that it's right. And I think that's kind of a bias among social scientists, at least as far as I've seen. There's a strong bias against false positives, but there's a trade-off. And the trade-off is, if you want 0 false positives, you're going to have a lot of false negatives. That is, you're just going to miss a lot of matches that are correct. So let's say that you say no false positives, and to get to no false positives, then you get like 50% false negatives, or conversely 50% coverage. Well, is that the right decision? I don't know. What if you could have like 0.1% false positive in exchange for 80% coverage, or 20% false negatives? Well, that sounds like a decent trade-off to me. And honestly, in the interest of reducing our support load, I decided not to just say, here are only the perfect matches, because someone's going to come back and say, I'm a power user. Maybe I want to look at matches within an industry or for a specific firm, and maybe I'll check them by hand. And so we decided to provide a larger set of matches where there's going to be some mistakes. But if we're going to do that, we can't just say, here's 30 million matches and some of them are wrong, because that's irresponsible. So we need to provide some guidance, and we decided to provide a confidence score, 1 through 10, where 10 means we're really sure this is right, and then 9 down to 1 is progressively higher levels of error. But even that's not enough, because what does confidence score 9 mean? Does that mean 10% false positives? If so, yikes. Because many people will infer that. Or does it mean 1% false positives? And so we actually spent a lot of our grant from the Sloan Foundation, which I also need to acknowledge. This work would not have been possible without a very generous grant from the Alfred P. Sloan Foundation. we decided we needed to provide an interpretation of the confidence scores. And so if you look at the first paper we published using this, we go through and find the matches at every confidence level, and those are the numbers that are in parentheses, and said, so for example, at confidence level 10, which is in the lower right-hand corner, we have 100% precision, which means 0% false positives, which is what a lot of people want. But if we do that, we're at, 83.5% coverage. That's not great. In fact, we could get to 93% coverage if you allowed just 1.2% false positives. Now you might say, wow, 1% is too much. I don't want that. But what you can do is you can look at the knee in the curve and say, well, maybe I want to go to confidence level 7 or 8. And that's going to get me into the 90s in terms of coverage with like 0.3% false positives. And maybe that's a good decision for you to make. But the key is you can make that decision. We give you a confidence score for every single match. And we give you this chart where you can use that as for guidance. Now, again, I think a lot of people using the data just chop it at confidence level equals 10. Again, simple things are simple. But if you want to do something complex, that's still possible because we're giving you more matches. Now, one dilemma that goes along with this is, do you share the test set that you use to generate this data? And we decided to do that. That's on relianceonscience.org. Just in the interest of transparency, so you can actually replicate our scoring. Or if you want to do your own algorithm and you want to test it, you can use our test sets. That's just, we've decided to make that available as well. Okay, so let me get back to the complementary assets that I was hinting at the next point. So again, many people want to understand the patents and also the scientific articles. Now here I need to provide a little bit of background into the database of scientific articles that we used for this because it influenced our decision. Now in previous projects, I had linked to the Web of Science, which is a remarkable database that is sold, no longer by Thomson Reuters, but by Clarivate. I need to update that photo there. And what Clarivate does is they actually pay publishers for data. And so you know that you're getting all and exactly the articles that have been published, and you get remarkable data about those articles, including do they depend on a government grant, and all this amazing data. But you do pay for it, and it comes with a license that says you can't post their data, understandably, right? No one would pay for it. And similar Scopus is kind of a similar thing. And so even though we had linked to the Web of Science, we couldn't post that data under our license. Now you might say, well, what's a way around it? What about Google Scholar? We all use Google Scholar. You go in there, you type a search, and it pops up and gives you the data. But you can't download the Google Scholar data. It's just not available for bulk download. And you can try to scrape it. You can write a web crawler. Good luck with that. I've been there. I don't recommend it because and I think, I'm not sure, but I think Google also pays publishers for data for the sake of completeness. And so that was not a possibility. But then just accidentally, I discovered another database, which a lot of people don't know about, which is being used a bit more, called Microsoft Academic. And if you go to, I'll just give you a link here, academic.microsoft.com, you'll find a website that looks remarkably like Google Scholar and does pretty much what Google Scholar does with one big difference. And that is you can bulk download all the data. Now, I think this is possible because Microsoft does not pay publishers for data. Rather, they scrape it from available sources and they create it completely automatically, which I believe means there's going to be more error in this data set. But it also means it's free and you can get it. And so that's what we decided to link to. So we link patents to scientific articles in the Microsoft Academic Graph, as they call it, so or MAG for short. And so our data file is basically patent ID and Microsoft Academic Graph ID. But at the time that this is different today, but when we started sharing this data, no one had really used Microsoft Academic Graph. Not many people knew about it. And we figured if we just provide, the MAG ID, then that's okay for the people who want to just get the count of papers. But for anyone who wants to investigate what's the nature of the citation, they would be stuck. So there's another dilemma. How do we make this available to people? Well, one thing we could do is is we could merge all the fields into our data file that we're going to provide, but that would make it ridiculously large. We don't want to do that. What else could we do? We could point people to the Microsoft data, which is available publicly on Azure. But it's a bit involved. You have to register for an Azure account. You have to give them a credit card. You have to set up an account. You have to set up a data lake and then install kind of set up the Microsoft Academic Graph data store and link that to your data lake. You then take the ID and send it to someone at Microsoft who makes that available for you to download. And then the data is pretty big and it costs roughly $80 to download it, because Microsoft charges for transport, unless you get a tax-free agreement with them, in which case you may or may not be able to get around the data charges. Suffice to say, it's a little complicated. And so we decided we could point people to Azure, but we worried about frictions. Now, there's a couple of folks who have done a service by downloading the Microsoft data and then just mirroring it. And so we thought of just pointing people to those mirrors, and that's probably what we should have done, although we weren't sure whether that person would update their mirror, because Microsoft updates this data set every single week. We didn't know if the mirrors would update that often, if ever. And even if there were a mirror out there, there's a problem because the Microsoft data is massive. So for example, the main file that has paper, year, title, volume, page numbers, etc., is 63 gigabytes. And thinking about our target market, but our target users, we're envisioning researchers who are using their laptops. Maybe they have a compute server, maybe the 1% have a compute cluster, but most people are going to be doing analysis on their laptops, and opening a 63 gigabyte file, not the easiest thing, right? And so what we decided to do instead was to actually create a redistribution of the Microsoft data, which is legal under their license. I'll talk about licenses more in a minute, where we chop up these files. And so we have a year file and a volume issue page file and a journal file and an author file and an affiliation file and a file just with the titles. Now the title one is massive. That alone is 17 gigabytes. Not much we could do to shrink that. But not many people want the titles. Most people want the year, or they want to know the journal or the authors or things like that. And by the way, Microsoft has a nice author ID if you want to track authors across papers. It's not perfect, but it's pretty good. And so we did that, which was a little bit of extra work, but it enabled us to facilitate people doing simple things, like they just get the master file of patent ID and paper ID, and then they can just merge on the year if that's what they want to do. They don't have to download the 63 gig file and then chop it up themselves. So that was the main thing we decided to do. And if you go on relianceonscience.org, you'll see that there are tons of files there, which are mainly the redistribution of the Microsoft data. Now, we don't redistribute all the Microsoft files. For example, there is a 200 gigabyte file that has the abstracts of the papers, although they're encoded, because to get around copyright restrictions, they can't just give you the abstracts as they show up in the papers. That would be copyright violation. Instead, they give you an index where they list all the words in the abstract alphabetically, and then they list the position in the abstract where that word appears, like "and" probably appears in the 5th, 10th, 15th, etc. And then you can reverse engineer the abstract. But that's a huge file, so we don't provide that. Okay. And then we'd also decided to create some missing complementary assets. So journal impact factor is something that's a lot of researchers want and we needed for our own paper. So we created that and we decided to open source that. And the other thing we got feedback on early on was people wanted to look at certain sections of the data. Now, if you're using the Web of Science and probably Scopus, like Web of Science has this beautiful taxonomy of 250 academic fields. And so you can just grab oncology or you can grab economics. Not so easy in the Microsoft data. What they do is they extract keywords from the title and from the abstract, and they provide the most frequent keywords for that art, or the key keywords for that article, but there's not categories. And so what we did is we built kind of a frequency weighted distribution mapping from the keywords to the Web of Science categories and some OECD categories. And so we decided to post that as well, hoping that would get people more comfortable using the Microsoft data for their analysis. Okay, I think that's everything on the what. Oh, I forgot one thing. So complementary assets, the main issue was the papers because people didn't know the Microsoft data set. But there's also the patents, right? Because people want to look at patents in a certain industry, in a certain category. So what should we do with patents? Well, we considered doing something similar to the Microsoft data where we redistribute the patent data, but that seemed like not a great use of time because for US data, there's patents view, and I adore patents view. In fact, the chopping up of files we did, we basically stole their schema, doing years separately from inventor. And I just love the way they've segmented the data. They've made the right decisions on compression, which I'll talk about in a bit. And so no reason for us to redistribute patents view, just go there and get their data. Outside the US, it's a little less straightforward. You can buy PatStat, but you do have to buy it, whereas the US data is free. You can download the source data, and I'm going to get a little bit ahead of my skis here because I'm not an expert internationally, but the DocDB data is downloadable from Google Patents. I'm not sure what the license restrictions are on that. And so we decided not to redistribute all of that. But we did find that what will happen is you'll get patents that are actually the same patent in multiple jurisdictions. And so they're really the same patent. And so there's a patent family that lets you kind of crosswalk those. And so we put the patent family index out there. Maybe that's unnecessary, but we felt like a lot of people would not want to double count in their research. And so we put that out there. Now, one thing that I don't think we did well is merging. Now, just because you have the data from PatentsView or from Google or DocDB doesn't mean you can easily merge it. For one thing is that Google uses different patent ID schema than USPTO, and we tried to crosswalk it so it looks, not crosswalk, but to massage it so it looks more like the USPTO for easier merging. But we didn't do a perfect job at that. So for example, one computer science grad student emailed me and said, "Hello, professor, we're using your data, but we can't match 40% of the patents to your data set. What's wrong?" And at first I was horrified. I'm like, oh no, everyone's been suffering in silence. You're the first one to tell me. And I said, why don't you send me a few of the ones that don't match and we'll look them up. And so this person sent me 10,000 patents that didn't match. And I just picked a few of them at random. And there they were on the USPTO website. And so I wrote back and said, hi, here they are. I think they're there. Are you removing leading zeros? And turns out that's the issue. Now, one way to look at that is, well, this person should have thought to convert the strings to not to delete the leading zeros. That's like something we should all do, but it's not obvious, and that's on me. So we should have provided some guidance on merging and saying, okay, if you're using this data set, think about leading zeros. If you're using the Google data set, the design patents in USPTO, they have a D at the beginning and then the number. Google will just have number -D and then a suffix after that. And we haven't really provided a guidelines on how to merge. And so that's something we need to do a bit better. That's something, if you're going to provide mergeable data, that I would pay attention to. And so I see Nick has logged in. And so Nick, maybe you can help me provide a guide on how to do a better job on this. Okay, so that's a lot on the what. Any questions on that before I trudge ahead? Okay, if not, we will talk about the where.
I have something to say. I mean, looking at what you have done, remarkable, Matt, but I see that you are just duplicating efforts that the Lens has already provided, the patent citations as well as the non-patent citations in work that we have published with Adam in 2018. And we made the data available in MAG, and what you have downloaded from MAG, maybe the non-patent citations. So just for the record, that all this effort could have been combined instead of duplicating what the Lens has already done and started since 2017 or 16.
So Ahmed, if I understand you correctly, you're claiming that my data set is redundant with what you've done?
I would say most likely it's redundant. The only advantage maybe that you may have is that you have added the in-text citation. and that we need to just look at it and compare if you have done that. And what is the extent of that addition?
Okay, well, let me clarify that for the record. So the data sets that we provided include, so for those that don't work with citations, there's two types. There's kind of the official citations that show up on the front page of the patent that are legally binding, over which the patent is declared to be valid. And then there are citations that appear in the text of the patent itself. So they're not one per line. It's like that, that slide I showed you early on. Those are, we call them in-text citations. Some people call them body text citations. And there are actually more of those than there are on the front page of the patents. And so what we have done, and what you can find at relianceonscience.org, is all of the front page citations and all of the in-text citations for patents worldwide. So I'm not aware of that being duplicative with the lens, but we can talk more offline. Okay, so let me continue on and talk about where, how we chose to share this data. So the first thing that we did is we considered a homegrown solution. Now, what do I mean by homegrown? I mean that you could put this data on your personal website, like Jeff Kuhn has done. Now, Jeff has done some remarkable data sharing work. What you see listed is just one of 4 or 5 data sets that he has shared. The one that's highlighted here, he looked at patents, citing other patents, and provided text similarity indexes for the citing and cited patents. So that's a remarkable achievement, and remarkable that he shared that. And it's on his personal website, gives him complete flexibility to do whatever he wants, and puts it under a license, and we'll talk about licenses in a second. Another approach, which is undertaken by Pedro Matos and John Baena, is they did a very, very nice work on what some people call entity resolution. What they basically try to do is say, for US patents, there's an assignee for the patent who owns it, but just like they don't require you to put a social security number for the inventor, there's no unique ID for the assignees. And lots of people, including people on this call, have spent many years trying to resolve the assignees by chopping off incorporated and prefixes and everything. Their approach was very different, and I thought very clever. They just took those strings and pumped them through a Google search and then matched up the ones that came back with the same URL. Very clever idea. I would never have thought to do that. And then they published their data. And when they did that, they decided to build their own website to host it. And so if you want their data, you go to the site they built, you click, you can put in your name and your contact info and what you want to do with the data, and then they'll get back to you. So this is kind of a homegrown or created. The advantages are you have total control, do flexibility, whatever you want to do. Of course, you have to build it. And there's a question of persistence. Will that website be there forever? Also, there's a versioning question, which is if you update the data set, can people get the old version that they used for the initial revision of their manuscript? And if their referees want them to just do a slight change, they may not want to get the new version of your data set. They just want to work with the old one. Then there's a question of support. And then the other thing, and this will seem like a trivial matter, but a download counter. So how many people have downloaded your data? Do you care about knowing? If you put it on a personal website, you might have to build your own download counter. But the good news is there are a number of repositories available that do many of these things for you. And so I'm going to switch to talking about just 3 of the many repositories that are out there that you should consider. First, I'll talk about ICPSR, and I put an asterisk next to it because there's 2 flavors of this. So this is administrated by the University of Michigan. It's been around for many years, and originally started as a curating service. So if you had a data set you wanted to share, you could pay the good folks at ICPSR to do all the things we're talking about today. Document your data, check for missing values, go through and make sure, and versioning and all those things. They then, I think more recently, added something called Open ICPSR, which is a website where you can just post data without paying anything and without interfacing with anyone. and they offer a number of features. So one thing, they offer archiving. So old versions of your data sets will always be available. And they put a new digital object identifier on every revision. So if someone wants to get your data 10 years from now, they can go back. The default capacity is 2 gigabytes, although I needed more like 30. So I wrote them and they said, okay, we'll increase your allocation to 30. And they were great about doing that. They have a download counter, and they do require registration. And so we started out with OpenICPSR, had a great experience, but we wondered whether the registration might be creating a little bit of friction. And so we were looking for a site where we wouldn't have to require registration because we weren't interested in tracking who used the data. Now you might be, you might want to know who your users are, and if so, OpenICPSR is the way to go. So another popular one, probably the most popular, I would guess, is Dataverse. Now, Dataverse is written on a code base, which I believe is written by Harvard's Institute for Quantitative Social Science. You can actually download the Dataverse and install your own Dataverse. The Harvard Dataverse is the one people usually post data on, and they provide all these same features, archiving, the DOI, although I think I heard in a session a couple weeks ago that the DOI is per data set. I could be wrong about that, so don't quote me. They have a 1 terabyte capacity per kind of archive that you set up, if I understand correctly. But they do have a per data file capacity limit, which at the time was 2.5 gigabytes. That may have increased recently. But in our case, and they provide a download counter and they don't have registration. So I've actually posted about 3 other data sets to Dataverse because they were less than 2.5 gigabytes. And again, this limit may have been increased recently, or maybe they're going to increase it. They say on the website that they will increase it if you ask, and we didn't go through that process. Maybe we should have. But because of that limit, we ended up going with a different solution. But I've had a great experience with Dataverse, and it may be the right solution for you. So let me tell you about Zenodo, which is the name that appears on our, when you type in relianceonscience.org, it goes to zenodo.org. Now, Zenodo is administered by CERN. These are the folks who brought you the internet. This is where Tim Berners-Lee invented hypertext, HTML, HTTP protocols. They also found the Higgs boson particle. Kind of exciting. I think they're going to be around, and they do archiving. They give DOIs for every revision. So we have about, I don't know how many revisions of Reliance on Science data, but you can go back and get the first one we posted in December of 2019. You don't have to register, and they have a 50 gigabyte default partition, which was just enough for us. And they have a download counter. So we ended up going with Zenodo mostly because of the capacity. There's a good chance that if we had worked with Dataverse, we could have gotten a capacity increase, or maybe they will increase the capacity. The point is there's a lot of great solutions. And what's really great about this is you don't have to build it yourself. And you don't have to be on, and for example, because if you put it on like on your faculty page, then if you change jobs, you have to migrate the data and tell people you're migrating. Maybe you put it on Squarespace or Wix. You know, how big of a file will they let you put there? I don't know. What if Wix goes under? Not that I expect they would. But I think these 3 are very safe bets in terms of persistence and being there for the long haul. And Bitsy put in the chat that yes, economic history data sets are an ICPSR. It's a great, I mean, both Dataverse and ICPSR are fabulous places to start searching when you begin a project, because there's a decent chance someone has built or shared a data set that you're already talking about. Okay, let me move to how, and I'll try and speed up a little bit because we want to be done by 1, I think. So, so the first how question is bulk data versus APIs. Now, for us, we never really thought of this as a dilemma. We were inspired in part by Patton's view, and we thought that most researchers would just want all the data and be able to grab the data and then subset the piece they want and use it that way. So we never really thought about doing APIs. Others have done APIs. Patton's view has added APIs, for example. And if we had commercial users who were more interested in subsections of the data, maybe we'd think about adding that. But what I was trying for is trying to minimize frictions. I didn't want anyone to have to learn how to code to use our data. And so our default was bulk data. Now that did create the problem of needing to make sure the files were small enough that you could load them on a laptop. But except for the titles file, which is 17 gigs, all the others are under 8 gigabytes. So pretty much manageable by anyone. And so we have no plans to add APIs. I guess we could, but we've actually never had a request to do that from the 34+ thousand downloads we've had. The next question is format. And this is another one that might seem obvious, but maybe isn't. So you could put in provide a proprietary format like Stata or R or SAS or whatever, or you could provide a flat file that is just the raw data. Now, there's obviously disadvantages to providing proprietary formats. What if someone doesn't have that format? What if they don't use that program? But there is one advantage, which is they tend to be smaller. As you provide a flat file, let's say you have let's say you want to provide patent data, excuse me, and I think IBM is still the biggest patent owner in the US, then the word international business machines is going to be repeated millions and millions of times in your data set. In a flat file, that's going to take up the same amount of space, whereas in a proprietary format, you could use an internal pointer and just shrink the file down. So that's a consideration. We went with flat files just for universality, for simplicity. Even there, this is a dilemma of, do you do comma separated values, which everybody understands, or do you do tab separated values, which can confuse people, but which eliminate having quotes around every field, so it can be smaller. We went with TSVs, again, following the lead of Patents View. And then there's the compression question. And because we had such big files, we wrestled with this for a long time. It turns out there are as many compression algorithms as there are types of files. Some are better for text data, some are better for non-text data. Ultimately, we decided to provide the chief file, the patent ID and Microsoft ID, as an uncompressed file for two reasons. One is that, believe it or not, I get emails asking me how to unzip files, and the fewer of those, the better. Second is that in some repositories, an uncompressed file will be represented. For example, if you post an uncompressed file on Dataverse, it will actually unpack the TSV or the CSV and show the fields in a display format so you can see exactly what the data looks like, which is really cool. So that's what we chose to do. We then zip the rest of the files, even though zip doesn't give great compression compared to something like 7-zip. But we didn't want to have a link to 7-zip and get people asking, how do I install 7-zip on we're being a little lazy that way. But again, trying to make simple things simple and reduce the support load. Documentation. So this is kind of straightforward, pretty simple. Just say what every variable is, where it comes from, what the type is. If there's enumerated values, describe what all those are. If it's a confidence score, describe where they can find out what the confidence score means. We provide the Microsoft Academic Graph ID. Microsoft has digital object identifiers for about 3/4 of the papers it has, and so we provide that. And it has PubMed IDs for a much smaller percentage, and so we provide that as well. And then again, because we do both the front page and the in-text citations, we tell you whether the citation appears only on the front page, only in the body text, or whether it appears in both locations. And there's a number of scholars comparing those two. And so that's a very key indicator to have. Okay, so another part of the how is kind of is to do with licensing. And this goes back to who your users are, kind of for whom you want to share the data. Now, one approach is to make it public access. So PubMed, for example, is a public access database. Anyone can download it, use it for anything. You don't have to give them any credit. You don't have to cite Medline. You don't have to say anything. It's public access. And that's probably the path to the very most diffusion of your data. Kind of one step back from that is to apply a license, and there's a variety of licenses you can apply. And I think Sam is much more the expert than I am. I'll just tell you about 3 licenses that I've seen used. So one is an attribution license. So this says you can use this data for anything you want to do. There's no restrictions on that. All you have to do is tell people that where you got it. And so the most common of these is the Creative Commons by license, which is Creative Commons attribution. There's also the Open Data Consortium by license, which is another attribution license, which is the one we use for reasons I'll describe in a second. But you can get more creative. You could say, well, look, I'm an academic, I'm making this data available, but I don't want you to go and make money off of my data. So you could use an attribution non-commercial license. Or you could say, I'm happy for you to use the data for whatever you want, but what I don't want you to do is take this data and generate a new data set and post that. I'm just not comfortable with that. And so you could have a no derivative license. In fact, if you look at Jeff Koon's license, he uses a Creative Commons attribution non-commercial no derivatives license. So you can use Jeff's data for non-commercial purposes, but you can't use it to create a new data set that you then post, if I understand the license correctly. Sam, I may have messed up. So now here's the important thing. Just because you put a license on a data set doesn't mean people will obey it. So you might say non-commercial use only, but someone could go and do what they want. And so another approach is to actually restrict access. So on the UVA patent entity resolution data set, at least when I got the data, I had to say who I was and also what I wanted to do use the data for. And then I think they have the option of deciding whether or not to give me the data. And that may be the route that you want to go. Or it could be that this decision is made for you. Now, in our case, we were using the Microsoft ODC, we were using the Microsoft Academic Graph, and the license on the Microsoft Academic Graph is ODC-BY, so Open Data Consortium Attribution Only. So you can use the Microsoft Academic Graph to do anything you want, and no one can stop you from doing anything. But if you make a derivative data set like we did, and I'll be right with you, Bitsy, you have to pass that license through. So I could not make our data public access even if I wanted to. I have to honor Microsoft's license. Okay, Bitsy.
So I was wondering about and I guess this is probably a question for Sam, but the question of no derivatives and how that interplays with journals' requirements for posting your data, because a lot of people are going to take their data and then significantly change it, and then the journal will ask for that posted, or perhaps journals are friendly to that and will deal with just your code.
My experience is that the journals will require that the data be published, and in that case, that means you still have to go back. You still have to get a custom agreement from the source to use it in a paper. So if you publish something under a no derivatives license, I guess you have two options. You could publish the entirety of the source data set and not publish any derivatives from it, like any extracted tables.
Really?
But you couldn't publish you couldn't make a composite of that in many other data sets. And it's a very hard, it's a license that was not really intended to be used with data, so it has strange interactions.
Wait, Sam, so just to build on Bitsy's question, so you're saying you can't use it and then produce a regression table using that under a no derivatives license? Really?
The regression table would be a derivative.
Really? I thought it would just be if you posted a data set. Oh, okay. So there's a spirit.
In copyright law, what constitutes a derivative is very much underspecified.
Okay.
And since it's the essence of what it means to be inspired by something and then to do something new, is that technically a derivative of everything that you've experienced? That's a gray area that people try not to plumb. But if you were exclusively making a new visualization, even just a visualization of errors from a public data set under no derivatives, there could be a claim. Wow. I think the lesson here is a no derivatives license is probably not what any of the data authors want, because I don't think I've never heard of a data holder suing someone else because they felt that this was that these things violated violated the law.
Yeah, yeah, no, I'm sure. Okay, so that's great insight. Thank you. Okay, so we're coming up on 1 o'clock. So I'll just to wrap up, I want to end with actually probably where we should have started, which is kind of the when or whether to share data. Obviously, if you're required to post the data for a journal, you do that. But what if you're not required? What if you're building a data set that you think or you know will spur other researchers, that will enable things to happen that couldn't happen before? There's a when question. Do you write 3 papers, 5 papers, and then make the data available? Do you harvest that data, or do you just give it away now and take your payment in citations? And if you do give it away, are you going to update it? Now, this comes back to last week. Gitan gave a very interesting discussion of his patent to product data set and how he's envisioning a business model to sustain it over time, because there are a lot of data sets that are updated through year X and not since then, because the grant ran out, and getting money for maintenance is not always as easy as getting money for a new cool idea. But actually on this, to harvest or not harvest, I want to cold call Adam, because I think Adam is probably the pioneer really of sharing data. And I just wanted to ask Adam, how did you and your collaborators think about making the patent citations data available so early? Because you could have held on to it for years. Can you just...
So the solution is to have Manuel as your co-author.
Okay.
Manuel and I went for a walk on the beach in Israel. And we were talking about, we had gotten a small grant from NSF to create what became the NMBR patent data set, citations data set. And I thought we should get a few papers published before we published it. And Manuel said, no, that's silly. The way we'll get credit for this is by publishing it, and everybody's going to use it and cite us. And for those of you who know Manuel, he tends to have strong views, and he's usually right, which is a good combination. So we did what he suggested, and it worked. So I'm a big believer in put the data out there and you'll get cited.
I was going to ask if you think in retrospect that you made the right decision, but you just answered.
Oh, absolutely. I mean, no question.
Okay. Because I've had a lot of people say to me, like, Matt, do you not understand incentives? Like, why are you giving this data away? Like, why don't you write 5 papers?
I mean, there is an issue which I guess we didn't really worry about too much, of in the world of overall scientific credit attribution, like what's the relative weight of a small number of highly cited papers versus a larger number of less cited papers. And I don't claim to have really analyzed that. So I did once have Svi many years ago tell me that the problem with my CV is that I didn't have enough bad papers on it. But I decided not to pay any attention to that evaluation.
So how many sites does your NBR paper have now? So like 3,000?
Well, it depends on where you look. I think on Google Scholar, it's over 4,000.
4,000, wow.
On RePEC, it's many, many fewer. They count much less stuff, I guess. I don't quite know.
Okay. Wow, that's incredible. So I'm at, I think, like 40 sites. So I have like 2 orders of magnitude to catch up with.
Well, but
so we'll
yeah, that was 30 years ago.
Yeah, we'll see. We'll see. But in my defense, for those who think I'm totally crazy, we did publish 3 papers using the Web of Science version of this. And actually what happened is, like, a lot of people kept asking me for the data, like, hey, can I use that? And we just couldn't give it away. And then we noticed the Microsoft database and said, oh, we could give it away. And that's what led to the collaboration.
I will also say there's an interaction between your second 2 bullets there, because one of the things that happens if you are successful in putting out a data base that a lot of people want to use. The update question just becomes enormous. And I think we've talked about this before in various subsets of this group, but there's still people writing papers today with the NBR data set, that the version that ends in 2006.
Yeah.
Which was itself created with a small grant from NSF to update the original data set, which had ended, I think, in probably early 90s, something like that.
And Adam, why do you think that's true? Even though I think PatentView has everything that your data set has, right? I mean, it has citations. It has, like, why don't people use PatentView instead?
Well, because.
Or am I wrong? Am I wrong about that?
Well, certainly a combination of PatentView and some other sources. I mean, I don't know. I don't remember if PatentView calculates like generality and originality, but
Oh,
the
that's
OECD,
right.
but the OECD does. I mean, there are other places that do it.
That's a good point.
But I think the main point is that information, despite the simple economics models, does not diffuse freely, and people just don't know what's out there necessarily.
Yeah, that's very true. No question. Great. And oh, by the way, speaking of the update issue, confession to make, we're a little behind. My job change and compute server change means we're a little behind in doing our own updates, but we're working on it. So hopefully we'll have an update soon. Okay, so that's all I had to say. I just wanted to say thanks for being here to talk about mundane issues like where to put your data, but hopefully you can avoid some of the mistakes that we made. And I also appreciated learning more about the no derivs license, which I did not understand correctly beforehand. Once again, please come see us in Ithaca. It's a lovely place to be. And thanks again for being here.